In section 3.4, we're finally going to talk about our first proof. So first we want to talk about the properties of equality. This is going to end up being kind of like a word bank of reasons that we're going to be using in proofs. So let A, B, and C be any real numbers. The addition property basically just states that if A equals B, then I can add some value C to both of those terms and the equation would still stay equal. You have the subtraction property, which is the same thing but subtracting some number. Multiplication is the same property, but now you're multiplying some number. The division property, the reason why I have that C is not equal to 0 in there is because you can't divide by 0, you get an error. And then the reflexive property, this should be a new one. That's basically saying that any value A is equal to itself. The symmetric property, if A equals B, then B equals A. I can flip around anything and it would stay equal. And then the transitive property states that if A equals B and B equals C, then I can conclude that A equals C. And that's kind of our third new property that we're learning. I would write all of these down. When I check these, I'm going to check to see that you have all these properties written down. I know it might seem redundant, but it's going to be important when we actually make our first proof. Another property is the substitution property. If A equals B, then B can replace A in any expression. And finally, the distributive property, we should be kind of familiar with this already. I could multiply some number A to the quantity B plus C. Now I get AB plus AC. That would be if I'm having the sum, and then difference, kind of same deal there. And we're going to learn a lot more properties throughout this unit in the next one, but we're going to stop here for now. Now, a proof is a convincing argument that uses deductive reasoning. They logically show why a conjecture is true. And the kind of proofs that we're going to be working with are two-column proofs. So we have our statements to the left and our reasons to back them up on the right. So in our very first proof, we're going to prove that if 3 times the quantity 2x plus 9 equals 57, then x equals 5. So we're going to have our statements and reasons. Now I'm going to start with that given statement. So 3 times 2x plus 9 equals 57. I always start with my given statement. And then finally, my last statement should say x equals 5, which is what I'm trying to prove. Next, I'm basically just going to solve. So what I would do first is distribute that 3 out. The reason is I'm using the distributive property. Next, to get the x by itself, I'm going to subtract 27 to both sides. I'm left with 6x equals 30. The reason I could do that was because of the subtraction property. And finally, I'm going to divide both sides by 6. And I'm left with x equals 5, and I could do that because of the division property. So you can kind of see here, I'm basically just solving an algebra equation right now, but the only kind of geometry thing that I'm adding is making it in a proof format. So all that I'm doing is I'm actually just physically writing down the reasons of each step. And I would be done here because I'm trying to prove that x would have to equal 5 in that equation, and that's what I did here. So let's move on to more of a geometric proof. My goal is that we're going to work our way up to a proof like this at the end of this unit and then in the next unit. I'm given that the measure of angle 1 is equal to the measure of angle 3 in this diagram, which we could see by those little arcs. I want to prove that angle AEC is equal to angle DEB. So I'm going to have my two-column proof. I have my given statement that I'm going to start with, and what I'm trying to prove will end up being my last statement. I'm going to start here. I see that angle 2 in the middle. I'm going to say angle 2 is equal to itself. That's a new property. That's the reflexive property. From here, I know that angle 1 and angle 3 are equal to each other, so angle 1 plus angle 2 should equal angle 3 plus angle 2. So I'm adding that angle 2 to both of them, and that's using the addition property. Finally, I could look at this diagram here, and I could see that AEC, that angle, is made up of angle 1 and angle 2. So angle 1 plus angle 2 is equal to AEC, and that's by the angle addition property that we learned last chapter. Similarly, angle 2 plus angle 3 added together makes up angle BED. So again, that's by the angle addition property. Now, I could see here that angle 3 plus angle 2, I could substitute that with BED. Angle 1 plus angle 2, I can substitute that with AEC. So I could rewrite that statement as angle AEC is equal to angle BED. And that's by substitution. That's what I'm trying to prove, that AEC is equal to DEB, so I'd be done. Now, I want you to write down this proof. We'll go over this a little bit more in class. This one might seem a little bit more difficult due to the fact that this is more geometric. We're going to work our way to be doing stuff like this. Tomorrow, we're mainly going to focus on the algebraic ones.